These are some of the details I learned about powering my accessories up here on a 2025 GS1300 adventure bike. This 25 BMW GS1300 adventure bike is the newest motorcycle I've ever owned. The next newest one I've had is 6 years older, that being the 19 RSV4 1100 factory Aprilia over there. So there's definitely some lessons I had to learn in trying to hook up all the accessories up here. The first thing you have to remember is that this is a CAN bus system. So the way I was used to it on older bikes is that you would connect something based on a power lead somewhere, switched power so that it wasn't on all the time draining your battery, such as on the Aprilia. When I connected the radar detector, I had a distinct 12-volt power source that was switched power. I simply connected wires to it. It had a fuse that went to the radar detector, and that's all there was to it. The first piece of information I got on this from Google is that the entire accessory system up here is 5 amp rating. So I thought I was going to find that all these things together had to be less than 5 amps, or there would be some fuse somewhere under the seat that would blow and have to be replaced if the draw went more than 5 amps. However, that's me thinking like technology was 15 years ago and not modern. As far as power usage on the front of the bike, the first thing you have is your dash or gauge cluster, and that's just part of the normal operation of the machine, so that we're not going to worry about as much. As far as accessories go, there are multiple sources for it. One of them is your little cubby hole up here has a USB-C down inside, and that is one source, and I'm using that to power my quad lock wireless phone charger. So the 12 volts goes from that cable to this, and then when I put the phone on, this device actually charges the phone. Another source over here is the DIN connector. So this is like a mini cigarette lighter kind of look, but that is another spot where you can have wires coming out of this to power things. And the other one was the power that went up here to the navigation mount, and I've used that power lead to not only charge the Garmin up here, but it also powers my Valentine 1 Gen 2. So I spliced that line out to go feed both of these things. Now currently the FLIR thermal vision camera system is getting its power from a cable here that plugs into the phone. So effectively, the phone charge is feeding the phone, which then feeds the camera power. What I would like to do to reduce the burden on the phone and overheat that is probably look into the DIN connector over here and using that to feed the power leads for the thermal camera instead. Now obviously my concern with all this is I didn't want to start blowing fuses by connecting too many things to the accessory ports up here. So I got out the manual and I started looking at the fuses. And again, I expected that all the accessory things up here would be on one 5 amp circuit, but that's not the case. So if we look up fuses in the instruction manual, we can see there is fuse layout 1, 2, and 3. 1 and 2 are under the passenger seat, and 3 is on the little side panel I'll show you in a second. The first thing I'll do is turn the key clockwise to pick up the front seat, and I'm going to put that just kind of off to the side. Remember, you've got a cable connecting for the seat heaters. And then I'm going to turn it counterclockwise to pull the passenger seat up. And in here you have 2 fuse assemblies. So you basically squeeze the side tabs and pull it out. Same with this one. So there you have 4 fuses. So this is fuse 1 and that's fuse 2. And over here, if you remove these two screws, this panel comes off, and you should have fuse layout 3 underneath there. Now those particular ones, I won't bother taking that off. It's 2 screws, pretty straightforward, but those were non-accessory related stuff. Now from the manual, it looks like on layout 1, you've got 5 amp for a multifunction switch, left auxiliary headlights, and you have 20 amp for the USB port, and voltage supply for cases and top case. So that 20 amp one is going to not only feed the USB port up here, but it's also going to provide a voltage supply for the left saddlebag and the top case back here, which surprised me because, again, what I've been told is that all this was on a 5 amp, including that. Fuse layout 2 is a 10 amp for instrument cluster, anti-theft alarm, central locking, etc., and then a 15 amp for keyless ride, cutoff for ignition, headlight, etc. And then in 3 over on that panel, you got a 50 amp main fuse, and then you got 20 amp for the radar detection, not Valentine, but like safety sensors, as well as windshield motor and stuff. So thinking again like I did years ago when I got my engineering degree, I thought, okay, I'll start pulling fuses to see what doesn't work anymore. And when I pulled the fuse for the instrument cluster, then the dash no longer worked, which made sense, right? The thing that surprised me a little bit is when I pulled the 20 amp fuse over here, which powers the USB port and the voltage supply for the cases, then the USB didn't work. However, in any case, the accessories for the navigation, the radar, and the DIN connector all still worked. So that tells me kind of that the fuse that's controlling the USB up here is separate from these other ones. So I called the BMW dealer and talked to the tech guy in service that knows a lot about how these work. And he told me flat out, you've got to quit thinking like you did years ago. These are CAN bus systems. They are not copper to copper connection. So what he said is, yes, you have these fuses, but really these kind of things are controlled by the CAN bus. And what the CAN bus is doing is it's controlling output. So if you overtax it, it's not going to blow a fuse like 30 years ago on an old Harley. It's going to limit the current draw to protect itself. He said, basically, think about it this way. The bike is smarter than you. You hook up what you need to it, and the bike will limit it to make sure it doesn't hurt anything. Now, if you have something that's just drawing X amount of amps because that's what it takes to power something on or off, then it's probably going to feed it that amount. But what it can do is reduce the amount of current going to charge something, because then it's just a matter of how fast or slow it charges. I can have the Garmin charging, which it does, but again, if the circuit gets overwhelmed and it's getting hot or it's getting close to its amp limit, this bike is smart enough to say, hey, I'm going to slow down charging his Garmin here because I can do that, and it just, you know, it won't charge as fast, and that's fine, but that'll slow down the amperage draw and protect itself again. So next step, what I'm going to do is put in the DIN connector here, and I'll show you how I do that to feed the power for the FLIR camera versus coming out of my phone. And I'm going to try that. And if everything works well there, then I can use that solution. If not, I can always go back to relying on the phone and charging it through that USB connector on the phone. And then that will allow the current to be higher on phone charging to keep up with it, but it will offload this other circuit up here. The first thing I ordered online was one of these DIN connectors. So this DIN connector will go into that mini cigarette lighter right here on this particular bike, plugs in. And again, this is going to be switched on power. And the other end of it, you can buy them with raw leads. I got the one that's got an SAE port, which is similar to what you see on like a battery tender. The nice thing about this is I can plug it in here, and if I want, I can leave it plugged in and just put the cap on it like that. Or if I want to plug, you know, whatever device into it, I can. If you have multiple devices, you can do that. Or you may have a FLIR for multiple bikes, and on each one you have something wired up like this. It allows you to transfer equipment, radar detector, whatever, back and forth between bikes. What I currently have for power leads are just these flying leads with raw wires, and I need to go from that to something I can plug into here for the DIN connector. To do that, I bought this gadget, which is just an SAE connector that'll plug into that side. It's got ring terminals that I will cut off. It is fuse protected, which is nice. So I'll cut the ring terminals off and I'll solder those to the flying leads so that it works. Now, the thing you have to remember with those SAE connectors is that depending on which side of it you're going, it can change the polarity. In other words, you can't always assume that the exposed terminal is hot or ground, or even that red and black are the right ones, because with battery tenders, you'll have a source, let's say, and one's hot and one's ground, but the mating one over here that goes to the battery or whatever could be different. So what I usually do is paint a little bit of red paint on the hot side of every connector, and you want to be real sure you've got it all connected properly so that this coming out here is, you understand which is the plus and which is the minus, as well as going in, which wires go to that all the way through. So use your voltmeter and don't make this mistake. And I'm going to power it up. So it's at 12.7, positive 12.7, and the red is the female one, which is contained, and the ground is the exposed one. So I'm going to put a little bit of red paint right there just to let me know that's the hot side. Now I've used my voltmeter and I know that that is the hot side, and I plugged in the ring terminal extension and I know that that's the hot side. So now I have to figure out, in this case, is my red still red or are these reversed? So I'm going to do that again with the voltmeter. All right, so if we take it apart like I just did, I've got one going in the hot side, and if I touch the red, I get nothing. If I touch the black, now it's conducting, which means that that black terminal is actually the one that's hot now. So that means it's reversed, and that's fine. I just have to know that. And you want your fuse to be on the hot side, not the ground side, so I have to change that as well. I've made my short little pigtail, so this is the one I bought. Again, it's red on the right side, goes to the red of that one. I swapped the fuse to the hot side. So now I'm just going to make sure that that's plus 12 volts and that's the minus with my voltmeter. And there it's positive 12 going that way. So I have it right. The fuse side is the hot side. So that's the one that has to go to the positive red power lead on the FLIR camera now. And check your work every step of the way, especially when you're dealing with cameras like that FLIR up there. So I've already done the positive and positive. I've got the positive going through the fuse, and that positive is going to the V1 input, V1 in, and the black ground is going to the ground side. So just make sure it's all solid before you finish soldering and putting everything final. Now the FLIR cable is all soldered, fused, connected where it needs to be, and shrink tubed. I've got red marks. I put fresh paint on it because it's smeared off. So I'm gonna let this dry before I drape it on the bike and end up getting red paint on the bike. And that's all done. So again, as I've said in the other videos on the FLIR, that cable is way longer than I'd like, so I might look into getting a custom cable made. But the point is, it's all gonna be functional now, and I'll be able to use the DIN connector here to feed that for the FLIR camera, and then just have the signal go into the phone where it'll sit in its cradle here. The only way to really test it out is once the paint dries, I'll plug it in and I'll take it for a ride. The only places I expect to even see any effect, if in the event that the amperage is more than what the bike wants to spit out, what will happen is either the Garmin won't charge as fast or the phone won't charge as fast, but everything else should be functional. And worst case, you know, I can unplug the DIN connector for the FLIR, and I can just rely on the phone for power for it. But I really won't know until I go do a long drive with it and see if, you know, does the phone eventually go dead? Is it using up battery faster than it can recharge? Same with the Garmin. Is it enough to keep that up to snuff or not? I really don't expect a problem, but it's just been a learning experience going through with this CAN bus and how these accessories all work. It's not something I'm used to. So just wanted to share what I've learned, and hopefully that helps you keep from letting smoke out of stuff. If you haven't done so, please click the link below to subscribe, click the little bell for notifications, and let's live for today.